Welcome to Math World. We are familiar with complex numbers in the form z equal to x plus iy. However, there are some alternate forms that are useful at times. In this video, we will look at one such form, that is polar form of a complex number. Let r comma theta, let r and theta are the polar coordinates of the points, say x comma y, that corresponds to a non-zero complex number, say z equal to x plus iy. Suppose in complex plane it's a real axis and this is the imaginary axis. Okay, this is my point z, that is x comma y. Okay, when I take it like this, it makes an angle theta with positive real axis. So this length is y and this length is x. Okay, now let me take this as r. Now we know from Pythagoras theorem, we say r square equal to x square plus y square, right? And we can even use trigonometric ratios. So if I want cos theta, then it is x by r, and sin theta is y by r. We know the rectangular form of a complex number, that's Cartesian form, that is z equal to x plus iy. Okay, now I'm replacing x by r cos theta, and I replace y by r sin theta. Now if I take r common, then it is cos theta plus I sin theta. Here r is, I can rewrite this over here, r is nothing but root of x square plus y square. In fact, it's nothing but modulus of z. So this is same as writing mod z into cos theta plus I sin theta, or simply r cis theta. And this is another way of writing, that's r cis theta. R into cos theta plus I sin theta is nothing but the polar form of a complex number, non-zero complex number z. Here always remember one thing, this r, which is nothing but the modulus of a complex number, which will never be negative. And when you take theta, it's nothing but angle measured in terms of radians that z makes with the positive real axis. Each value of theta is called argument of z. See, set of all such values of theta is denoted by argument z, or we can even say amplitude of z. That is, theta is nothing but argument of z. It's written arg z. Okay, it can be any of the infinite possible values of theta, each of which can be found by using the relation tan theta equal to y by x. Okay, have to make sure that this theta lies in the correct quadrant. Depending on the signs of x and y, we have to decide what is theta. Okay, and that theta is nothing but argument of z. You will get many possible values for theta, but depending on particular quadrant, you have to decide particular value for theta. Any two values of argument z will differ by integral multiple of 2 pi. Okay, say suppose something like this. Okay, here z is my point and z equal to r cis theta, suppose. Okay, this is the angle theta. Okay, positive real axis, it's making an angle theta. Now see, when it takes one full clockwise direction, then one more will be theta plus 2 pi, theta plus 4 pi, like that, increasing the angle theta, which is really just increasing the angle that makes the point with positive x-axis, and you are rotating the point about the origin in a counterclockwise direction, so that theta changes theta to theta plus 2 pi, theta plus 4 pi, like that, theta plus 2n pi. Okay, so new value of argument of z we can get just by adding the multiple of 2 pi onto the original value of argument of z. Like that, you can you even start decreasing the angle theta by 2 pi in clockwise direction. We get theta minus 2 pi, theta minus 4 pi, like that. Therefore, we can say if theta 1 and theta 2 are two values of argument of z. Okay, two possible values of argument of z, then they differ by the angle integral multiple of 2 pi. I mean, theta 1 minus theta 2 is nothing but 2n pi. One more thing we can observe, that is z equal to r cos theta plus I sin theta is a parametric representation of a circle of radius r. In fact, this is r, and centered at origin, and that it will trace a complete circle in a counterclockwise direction as we increase the angle theta from theta to theta plus 2 pi, theta plus 4 pi, like that. Okay, so you are getting different values for argument of z. You are getting a set of values for argument of z. Okay, now the principal value of argument of z, and it is denoted by capital A arg z. It is nothing but the principal value of argument of z, and this is it's nothing but in fact 2n pi minus argument of z, or you can even write the relation like this. Argument of z is nothing but argument of z plus 2n pi, where n can be 0 or it can be plus or minus 1, plus or minus 2, like that. The principal value of argument of z is the unique value of argument of z that lies in the range, say, minus pi to pi. Unique value of argument of z which lies in between minus pi to pi and is denoted by argument of z. Okay, now let us take few problems and I'll tell you how to find the angle theta, that's argument of z and all. Okay, so let us take first problem. Express the complex number. Express the complex number 4i using polar coordinates. They have given you the rectangular form of a complex number, that is z equal to x plus yi. Here it is 4i only, so I can write z equal to 0 plus 4i. In this case x is 0 and y is 4. Now first thing we have to do is have to calculate r, that is nothing but modulus of z, which is nothing but root of x square plus y square. In this case it is 0 plus 4 square, so that is 16. Root 16 is 4. So the value of r is 4. Now have to calculate theta. We can calculate theta by using the formula tan theta equal to y by x, right? Here x value is 0, so 4 by 0, it's not defined, right? So what is the value of theta? Theta is nothing but pi by 2. Okay, here in this example both x and y are positive, so it's very easy to calculate the value of theta. Okay, so theta is pi by 2. Now I have to represent this in terms of polar form. So z equal to, it's r cis theta, in the sense r into cos theta plus I sin theta. Value of r is 4, so 4 cis pi by 2. Okay, if you want you can write 4 into cos pi by 2 plus I sin pi by 2. If you put the values for pi by 2 over here, you will get this is equal to 4 pi. This is the polar form of a complex number 4i. Now the other way, like they'll give you r and theta and you have to represent polar form into a complex number in a rectangular form. I'm sorry. Find the rectangular form of the complex number given that r is 13 and tan theta is 5 by 12. We know tan theta equal to y by x, and that's given 5 by 12. Okay, and we also know r equal to root of x square plus y square, which is nothing but 13. In this case they have already given that. Now z equal to r cos theta plus r sin theta. See, when we have substituted here tan theta equal to y by x, which is equal to 5 by 12, we know x equal to r cos theta, right? So x value is 12 and r is 13, so cos theta is 12 by 13. Similarly, y equal to r sin theta, and it is 5 equal to 13 sin theta. Now we know z equal to r cos theta plus I sin theta. This is the polar form. R cos theta, we know r cos theta is 12, right, and r is 13, and you can either you directly write r cos theta is equal to 12 and plus I into r sin theta. R sin theta is 5, that's 12 plus 5i equal to z. This is the rectangular form of a complex number. Okay, these two types. Okay, major type. Now the thing is, you are given with the complex number which is having a negative real part or negative imaginary part, and how to find argument of z. have to calculate theta, and depending on that, depending on the signs of x and y, you have to find argument of z. So how to do that? Let me take the third problem. Say here the z is minus 1 plus I into root 3. Write this in polar form. Okay. So here x is negative, that is minus 1, and y is root 3. Okay. Now have to calculate r first. When you have to write it in the polar form, first thing you have to do is you have to calculate modulus of z, that is root of x square plus y square. Y is root 3 and x is minus 1, so it's 1 plus 3, that is 4, and root of 4 is 2. Okay, now have to calculate tan theta equal to y by x. Here, in fact, I can even write theta equal to tan inverse of y by x, and here it is y is root 3 and x is negative, that's minus 1. Now, see, I hope you know this. When we are taking tan inverse, okay, to calculate the argument of z, this is the these are the values of theta in different coordinates. When you have both x and y, then you both x and y positive, then that's the first quadrant. You are simply taking the angle theta, just like how we did in the previous problem. Here there both x and y was positive, z equal to 4y, that problem. Okay, so we directly took the value of theta, that is pi by 2 in that case, because x was 0. Okay, now when it comes to the second quadrant where x is negative and y is positive, in that case, when you are choosing angle theta for argument of z, to take 180 minus theta. And for the third quadrant where both x and y are negative, in that case you have to take theta minus 180 or minus of 180 minus theta. It's left to you, you can write it anyway. Okay, theta minus 180. And when it comes to fourth quadrant where x is positive and y is negative, you just have to take the negative value of angle theta. I hope you know this. This is the basic information we learn in trigonometry. Okay, now what happens here? Here x is negative, right? When you just ignore the sign here, then it is tan inverse of root 3, so that theta will be pi by 3, right? So now for calculating argument of z, we have to take 180 minus theta because x is negative, right? X is negative, so it's 180 minus theta. When you ignore the sign, what's the angle you are getting? Tan theta, theta equal to tan inverse of root 3, that is angle pi by 3. That angle we have to consider here, so that 180 is nothing but pi minus pi by 3, so that it will be 2 pi by 3. This is argument of z. This argument of z lies in second quadrant, and this angle lies between minus pi to plus pi, so that itself is a principal value of argument of z, that's capital argument of z, which is nothing but 2 pi by 3, which lies this angle. Since this angle lies in between minus pi to plus pi, that argument of z itself is a principal argument of z. Now the thing is, you have to write polar form of this. Okay, so I'm just writing the z equal to r, I have got 2, and cis 2 pi by 3, or you can write 2 into cos 2 pi by 3 plus I sin 2 pi by 3. This is the polar form. Let me take one more. Say suppose z is purely real, that's minus 9. Okay, you write this in terms of polar form. When you have this, x is minus 9, right? And what is y? This is same as writing I plus I into 0, right? So y is 0 now. What is r then? R is root of x square plus y squared, so it's 9 only. Then tan theta equal to in fact 0 by minus 9, it's nothing but 0 only, so theta is 0. For a negative real number you can directly write in fact angle theta is 0, and argument of z will be 180 minus theta because x is negative. Okay, 180 minus 0, so it's 180 degree, that's pi. Okay, so z can be written as 9 cis pi, or you can even write 9 into cos pi plus I sin pi. Let me take one more where both x and y are negative. The fifth problem, represent the complex number z equal to minus 1 minus I in polar form. See, writing the polar form is not so difficult, but the thing is you have to be very clear with angle theta. That's the argument of z or amplitude of z. Okay. So here in this case x is minus 1 and y is also minus 1. What is r? That is modulus of z, which is nothing but root of x square plus y square. So minus 1 square is 1, minus 1 square is 1. So it's root 2. Okay. Now tan theta equal to y by x, which is 1. Both are negative. X is negative and y is negative. So the argument of z we are writing, argument of z is nothing but theta minus 180 or theta minus pi. What is the theta over here? For this, if you ignore the signs, then the angle theta is nothing but pi by 4. Right, tan theta is 1. So it's pi by 4 minus pi. Right, so it's minus 3 pi by 4. So z equal to root 2 into cis minus 3 pi by 4. This is the next problem. They have just asked for principal argument of z, and z is I by minus 2 minus 2i. So first thing is we have to simplify this so that it is very easy to calculate r and theta. Okay, so for that sake I'll just multiply and divide by conjugate of the complex number. Okay, conjugate of the denominator, in fact, that's minus 2 plus 2i divided by minus 2 plus 2i. So think this will be minus 2i and plus 2i square divided by, this is minus 2 into minus 2 will be 4 and minus 4i, this is again plus 4i and minus 4i square. Okay, I'll just simplify this. I square is minus 1, so this will be minus 2, so minus 2i minus 2 divided by here this 4i will get cancelled. I square is minus 1, so this will become plus 4 and 4 here, so it will be 8. That's same as writing 1 by 4 into in fact minus 1 by 4 into 1 plus I. Okay, now have to calculate r, that is root of minus 1 by 4 whole square plus minus 1 by 4 whole square. That's 1 by 16 plus 1 by 16. In fact, this is nothing but 1 by 2 root 3 or root 8. Okay. Now have to calculate theta. Theta is nothing but tan inverse of y by x. Tan inverse of y by x, y is also negative and x is also negative in this case, so it must be equal to 1. So tan inverse of 1, that's angle is pi by 4. But argument of z, when both are negative, both x and y are negative, it is theta minus 180 degrees. So it's argument of z equal to theta minus pi. Theta is pi by 4, I'm sorry, pi by 4 minus pi, so it's minus 3 pi by 4, same as the previous one. Okay, so argument of z is minus 3 by 4 because it lies in between minus pi and pi. Okay, now the thing is, suppose the complex number is written in this form. Suppose, okay, say z equal to root 3 plus I power 6 7 or something like that, and you need to rewrite this in polar form. How will you do? I'm so sorry. Yeah. How to write the polar form of this complex number when the complex numbers are written in terms of powers of something. Okay, so in that case, going through this method is quite difficult. So for that sake, we have to rewrite this complex number in terms of exponential form. How to write that? I'll teach you that method, that is exponential form of a complex number, in my next video. Thank you.